Hello friends, welcome back to your UPSC. So now we will start with another topic of physical geography, that is climatology. The applied part of geomorphology will be completed with applied climatology and applied oceanography. So the first topic in climatology will be air pressure and atmospheric circulation. So let's get started. Now, in climatology, our first topic will be atmospheric pressure and circulation. What exactly is atmospheric pressure? Atmospheric pressure is also known as air pressure. Air pressure simply means a total weight of a mass of a column of air. So this is a column of air above per unit area at sea level. So this mass column of air, the weight it is applying on a area at sea level is known as air pressure. Now we will study about pressure belts. There are basically 7 pressure belts on the globe. So the first pressure belt is Equatorial Low Pressure Belt. Then we have two subtropical high pressure belt. Then two subpolar low pressure belt and two polar high pressure belt. Okay. So total we have 7 pressure belts. Now on the basis of mode of genesis, like how they are origined or how they actually came into existence, we have two broad categories of pressure belt. So the first category is thermally induced pressure belt, which include polar high pressure belt and equatorial low pressure belt. And next we have dynamically induced pressure belt, that is subtropical high pressure belt and subpolar low pressure belt. They are dynamically induced. So what does thermally induced pressure belt means? Thermally induced pressure belt means the one which are originated or which are formed due to thermal conditions, that is temperature. So the high pressure belt means there is low temperature, and low pressure belt means there is high temperature. While dynamically induced pressure belt means, see, in a subpolar low pressure belt we can easily see that there is low pressure, but in this area we have low temperature too. So in this type of low temperature, low pressure can't be induced thermally. So the other reasons, that is due to rotation of earth or due to convergence of wind, etc., etc., the pressure belts are formed. So these causes of formation of pressure belts are known as dynamically induced pressure belts. Okay. So now we will study equatorial low pressure belt. We will study all the pressure belts. So the first pressure belt is equatorial low pressure belt. Equatorial low pressure belt, it ranges from 5 degree north to 5 degree south. But this range is its ideal position. But it does not stay stationary, as it shifts northward and southward with the movement of sun. So during summer scholastic it moves towards north, that is it moves towards 10 degree north to 0 degree, and in winter scholastic it ranges from 0 degree to 10 degree south. Okay. Now what happens in equatorial low pressure belt? See, this is the land. Due to direct rays of sun, the ground get heated up, and because it get heated up, the air near it also get heated up and it rises because it becomes light. And because it is rising, this area experiences low pressure, and hence we see low pressure belt in this area. And there are frequent calm condition in this belt, and because of which this area is known as doldrum. Okay. Now Now we will look on to first we will look on to polar high pressure belt. Polar high pressure belt is also thermally induced pressure belt. it is at poles. Okay, that is 85 degree to 90 degree, north and south. Okay, they are thermally induced. Why they are thermally induced? Because the temperature here is very low, and because the temperature here is very low, the low temperature induces high pressure. Why it induces high pressure? Because see, when the temperature is very low, the air, it condenses, it becomes heavy and it settles down. And because the air is settling down, this area experiences high pressure, because of which this whole belt becomes high pressure belt. Now we will look into the dynamically induced pressure belts. So the first dynamically induced pressure belt is subtropical high pressure belt. Subtropical high pressure belt, it extends between the latitude of 25 degree to 35 degree in both the hemispheres. Okay, so this high pressure belt is not thermally induced, because this zone, besides the two, see this zone, besides 2 to 3 months, that is winter months, it has quite high temperature all over the year. Okay, whole year, throughout the year. So this belt owes its origin to the rotation of Earth. Why it is originated? Because of rotation of Earth and sinking and settling down of wind. Now how this happens is, see, we have low pressure, subpolar low pressure belt, then we have equatorial low pressure belt. Now here we have this region. Now equatorial low pressure belt, the air rises and it spreads and it starts moving in both directions. So we will consider this belt of air, and here also the air, it rises and it spreads in both directions. Now here we will consider this belt. Okay, this belt and this belt, as they come towards each other, they meet and here they converge. Because of their convergence, they settle down, and the area they are settling down, this area where the air is settling down, this area becomes high pressure. Okay, and because the air settles down here, the air is settling down here, so on the ground what will happen is the wind will move from high pressure to low pressure. Okay, so this area will be calm, and because this area is calm, here we will see that uh, we need the convergence of wind. In the lower ground level, we need convergence of wind to get rainfall. Okay, in monsoon we will study that. So when the winds converge, they bring rainfall, but here the winds are diverging, and because of this divergence of wind, this area is calm, and we can find most of the hot deserts in this area only. Okay, so in this pressure belt, subtropical high pressure belt, we will see most of the hot deserts, and this belt is also known as horse latitude. Why it is known as horse latitude, that we'll study later. Now the last one is subpolar low pressure belt. Subpolar low pressure belt, it ranges between 60 degree to 65 degree north and south. Now this is also a low pressure belt. This is also a low pressure belt which is in the area of very low temperature, that is considerably low temperature, where low pressure can't be induced thermally. Now why this area is having low pressure? So the main basic reason why this area is having low pressure is the surface air, it spreads outward from this zone due to rotation of earth, and the low pressure is caused. So see, the earth actually it spins, and when we have tapering end, we will see that near the axis, when we are near to the center of rotation, the speed, it increases. Okay, the speed it decreases. Now what will happen is the air here will spread because of rotation of earth, and because it is spreading, so because it is spreading, this area will experience low pressure. Okay, this area will experience low pressure, and that is how subpolar low pressure belt is formed. But this low pressure belt is not like regular. It is much more regular in southern hemisphere. Why it is regular in southern hemisphere? Because southern hemisphere is having most of the part as ocean, while the subpolar low pressure belt in north is having its part in continent. And because we have continent, we have land mass. The land mass we know get easily heated up in the summer, and because of which the area here it discontinues. Okay, so in this area water is over dominant, and here that is why this pressure belt we can see is continuous, unlike the one in northern hemisphere. Okay, so that was about pressure belts. Now we will look into shifting of pressure belts. Now how pressure belt shifts. So pressure belt seldom remain stationary, because they occasionally remain stationary because the the pressure belts are basically induced by sun and its movement. Okay, so it changes because of northward and southward movement of overhead of sun. Okay, contrasting nature of heating, cooling of land and water. Now because land it gets heated up very fastly, and water it gets heated up very slowly, but it remains heated up for long time as compared to land, which get heated up also quickly and get cools down also quickly. Okay, so because of which what happens is, as I told you that in subpolar low pressure belt is discontinuous in northern hemisphere. Why? Because it has overdominance of land mass, while in southern hemisphere we have overdominance of ocean body. So because of which we can see that the water has quite stable conditions that actually induces stationary, gives stationary or gives consistency to pressure belts. Okay, next we have another thing is low pressure belt develops maximum between 2 to 4 p.m. So if someone asks why it is maximum, why low pressure is maximum at 2 to 4 p.m., because at 2 to 4 p.m. we have good amount of sunlight is captured by the earth, and the temperature is highest. Diurnal range of the temperature is highest in this time, and because of which when we have high temperature we have low pressure. Okay, so the low pressure develops between 2 to 4 p.m., while the high pressure it develops between 4 to 6 a.m. Okay, and the ideal position of pressure belt can be seen at the time of vernal equinox, that is on 21st March when the sun shines directly on the equator, and autumnal equinox, that is on 23rd September. Okay, now we will look into pressure gradients and air circulation. So what exactly are pressure gradients? Gradients we all know, gradient is slope. So how we have slope in this area, this thing, that is, this is high pressure and this is considerably low pressure. So this is gradient. So the difference between the pressure belts of any two area is known as pressure gradient or barometric slope. Now, pressure gradient is actually perpendicular to the isobars. So these are isobars. Isobars are the lines with joins similar temperature, the points having similar temperature. Okay, so they are actually perpendicular to them, but due to Coriolis force, they acquires or they tilt or and they crosses this sorry pressure gradient. It crosses the isobars at an acute angle, okay, instead of moving perpendicular. Now, the horizontal pressure, the rotation of Earth, and Coriolis force, fractional force, and centrifugal action of wind, they actually causes tilting of winds, okay, and wind blowing parallel to the isobars, generally at high temperature. See, winds never blow parallel to isobars. Why? Because of this reason, okay. So if they are moving parallel to isobars, that is generally at the height of 600 meter, it is known as geostrophic winds, okay. Now, winds always move from high pressure belt to low pressure belt, that we all know. They deflect due to Coriolis force, and how they deflect is that we can see in Ferren Law. The Ferren Law is the law which gave the direction or deflection of wind when it moves. Now, we see that wind deflects towards right in its northern hemisphere, and in southern hemisphere it deflects towards its left. So what does this mean is, see, we have equatorial low pressure belt, then we have subtropical high pressure belt here and here. Now what we will see is wind always moves from high pressure belt to low pressure belt. So wind will move in this direction. But due to Coriolis force, it will tilt its direction. Now, in which direction it will deflect? So the deflection is studied on the basis of Ferrel's law. So now what Ferrel's law says is that, like, this is a man, okay, it is standing here, its back is towards high pressure because the wind is coming from that direction, and its face is towards low pressure because the wind is moving towards this direction. Now, when when it is facing like this, so the wind will tilt or will deflect towards its right hand. Okay, this is its right hand. So wind will deflect towards its right hand. So this is the direction of wind. Now next is when it is southward, so the wind will move from high pressure to low pressure like this. Now the back of the man will be like this. This will be the back of the man, that is towards the subtropical high pressure, and it will face towards equatorial low pressure. Now here the wind will move towards, or wind will deflect towards its left hand, okay. So this is what happens in this air circulation. In the northern hemisphere, the wind will always deflect towards its right hand, while it will always deflect towards its left hand in the southern hemisphere. Okay. Now, as we have completed pressure belts or air pressure, now we will look into air circulation. So now first we will classify winds. Winds are basically classified in two, that is permanent winds and variable winds. Permanent winds are also known as invariable winds or prevailing winds. They they are actually global winds which run flows throughout the year. Okay. For example, trade winds, westerlies, and polar winds, etc. And others are variable winds. Variable winds are further divided into various categories. So they are seasonal winds, local winds, mountain winds and mountain breeze and valley breeze, land and sea breeze. So they are basic categories of variable winds. So we have permanent wind and we have variable wind. Permanent wind we have trade winds, westerlies and polar wind, and variable winds are further classified into four, that is seasonal wind, land breeze, sea breeze, mountain breeze and valley breeze, and lastly local winds. So today we will complete polar winds, permanent winds. Now permanent winds are also known as planetary winds. They are related to thermally and dynamically induced pressure belts. They flows in them only. Okay. So we can consider this diagram as the wind. Circulation of wind we will learn through this. Okay. So first wind is wind in tropics. Wind in tropics means this area. Now it flows between 30° north to 30° south latitude. It is categorized by doldrum, equatorial westerlies and trade winds. So first we will study about doldrums and equatorial westerlies. What exactly are doldrums? Doldrums, I have told you, the calm belt is known as doldrum. So the belt of low pressure is known as equatorial trough. Trough, why? We have crest and trough. Okay, so the trough is low lying. So it is also known as equatorial trough. And it ranges between 5° north to 5° south. Okay, it is actually occurring between ITC. ITC is actually Intertropical Convergence. What is intertropical convergence? See, here we see what happens is we have equatorial westerlies and we have trade winds. So some people say, some meteorologists they say that they are fronts. So they call it intertropical fronts. But front actually occurs when we have two air masses that have contrasting characteristics. That is, this one is warmer and this one is cold air mass, and this is warm air mass. And if they converge, then this is known as front. But here the case is, this is also a warm air mass and this one is also a warm air mass. So basically it is more known as intertropical convergence. And intertropical convergence is divided into two according to its hemispherical existence. So the first is north tropical convergence and the other one in the southern hemisphere is south tropical convergence. So the doldrum exists between them. Now we have trade winds. Trade winds are actually between equatorial low pressure belt and south tropical high pressure belt. So this is south tropical high pressure belt and this is south tropical high pressure belt and this is equatorial low pressure belt. So the wind will move from high pressure belt to low pressure belt in both the areas, okay, in southern hemisphere and in northern hemisphere. So in northern hemisphere what will happen is the wind is moving from high pressure belt to low pressure belt. Now it will deflect towards its right, okay, and in southern hemisphere it will deflect towards its left. So the movement of will be like this, that is northeast direction here and southeast direction here, okay. Now next is horse latitude and westerlies. What is horse latitude? Horse latitude, it is dynamically induced subtropical high pressure belt. and we have studied this subtropical high pressure belt here. It is between 25 degree to 35 degree. Okay, so 25 to 35 degree. And due to anticyclonic condition, what happens in anticyclonic condition is, here we have high pressure and other sides we have low pressure, so air moves outwards. Okay, this is anticyclonic condition. So this area is very stable, calm, dry, and it has weak atmospheric circulation. Okay, so it has weak atmospheric circulation, and here we have very calm conditions, because of which we have dry conditions and we have majority of deserts, hot deserts existing here. Okay, this area is so calm, and it is also popularly known as horse latitude. Why it is not known as horse latitude? It has very old story associated with it. What happens is, the trade winds were used for, why they are called, basically why they are called trade winds. They are called trade winds because they were used for trading. Okay, so the merchants used to trade. Now when they came across this area is having calm conditions, and the air, it becomes stagnant sometime. Okay, so these merchants used to sail in the ship, and the ship was carrying horses. These horses were used by them. See, when they reached the land, they used to put the goods on the back of the horses and they used to trade it. So when the ship was stuck in the ocean in these areas, what they used to do is, to make the ship light so that it can move, they used to throw horses here, and because of which this area came to be known as horse latitude area. Next we have westerlies. Westerlies are actually, they are the winds which blow from south tropical high pressure to subpolar low pressure belt. Okay, south tropical high pressure, subtropical high pressure to subpolar low pressure belt. Now at subpolar front, that is here, we can see polar fronts are actually formed. Cyclonic fronts are formed because of convergence of two contrasting air masses. So here in tropicals, we have seen that the air were converging, but they were not having contrasting characteristics. But here they will have contrasting characteristics. Why they will have contrasting characteristics is, see here the one wind, we will see it here. See, we have polar high pressure here. Then we have subtropical low pressure, and then we have high pressure here. Now from subtropical low pressure, the winds will be coming, just a second, sorry, from subtropical high pressure and subtropical low pressure we have. From subtropical high pressure, the winds are coming to subpolar low pressure. Okay, and here the winds are coming from subpolar high pressure to subpolar low pressure. These winds are warm and humid, while these winds are cold and dry. Okay, so they are having contrasting characteristic, and they converges in this area, and fronts are formed, and because the cold and dry wind is more dominant, this front is known as cold front. Okay, now in northern hemisphere, because we have land, dominance of land, they are not as violent, but In the southern hemisphere, they become very stormy. And because they become very stormy, they are called by various names according to their velocity. So, on 40 degrees south, they are known as roaring 40s. In 50 degrees south, they are known as furious 50s. While in 60 degrees south, they are known as screeching 60s. Okay. Lastly, we have polar winds. Polar winds are actually, we have low pressure developed due to dynamic factors on 60 degree north to 65 degree, 60 to 65 degree north and south. That is, low pressure is developed here. Okay, that is subpolar low pressure. Now, this low pressure is persistent in summer but it disappears in winter. Okay, we can see it in summer but in winters it disappears. Why it disappears? Because summer we have kind of heated up land, so the air will rise up, and because air will rise up, there will be low pressure in this area. Okay, but in winter the conditions become very cold, so the atmospheric air they settle down, and because they settle down, this area becomes high pressured area, and the low pressure belt it disappears. Okay, and at the northward area, that is on the polar region, we have very low temperature. Because of that, we have very high pressure here. And this wind blows from subpolar low pressure to polar high pressure belt. Okay. And these winds that are blowing from subpolar low pressure to polar high pressure belt, they are known as polar winds. Now, we will look into seasonal shifting of winds, how the winds shift according to time. So, first we will see in summer scholastic, that is 21st June. Now, in 21st June, what happens is the sun is shining bright in the northern hemisphere on Tropic of Cancer. Okay, so when it is shining on Tropic of Cancer, the doldrum, or we can say equatorial low pressure belt, it shifts towards north. Each and every belt they shift towards north. The range of this one is from 0 degree to 10 degree. Okay, and the winds also, the trade winds also, they are carried upward, further upward. So in their ideal condition, they actually flow from 5 degree. Their range is from 5 degree. Okay, till 5 degree, but in summer they actually crosses their range and they move till flow till 0 degree. Okay, so the range it changes from 0 degree to 10 degree, equatorial low pressure belt, and subtropical high pressure belt, its ranges changes from 35 degree to from 30 degree to 35 degree to 35 degree to 40 degree. Okay, so 30 degree to 35 degree is their ideal condition, but in summer, that is during summer scholastic, their range it changes to 35 degree to 40 degree. And in ideal condition, we will see that when the sun is shining bright on equator, so on equator it shines twice a year, that is on 21st March and 23rd September. So that time the range of equatorial low pressure belt is from 5 degree to north to 5 degree south, while of subpolar high pressure belt is 35 degree to 30 degree north and south. And in winter scholastic that occurs on 23rd December every year, the every belt shifts southward. Okay, so the range of equatorial low pressure belt will be 0 degree to 10 degree south, and the high pressure belt will be subtropical high pressure belt range will be from 20 sorry from 30 degree to 25 degree north and south. Sorry, from 30 degree to 25 degree north, while in south it will be 35 degree to 40 degree south. And in summer scholastic, the range will be, at southern hemisphere, the range will be 30 degree to 25 degree south, while in northern hemisphere it will be 35 degree to 40 degree north. Okay. Now, as we have completed the circulation of planetary wind, we will look into tricellular meridional circulation of atmosphere. Tricellular meridional circulation of atmosphere. It is actually total circulation that is on the ground level and upper atmospheric level. So, this is low pressure belt. Okay. Here the wind, because it gets heated up, it rises. And because the wind is collected, the air is collected here, this area becomes area of high pressure, while this area is area of low pressure. And as the winds are going down, that is, wind are not staying here, this area becomes area of low pressure and this area becomes area of high pressure. Okay, that is high pressure. Now this is 3D cross-sectional diagram. So what happens is, in this one, as the winds are coming from high pressure belt to low pressure belt, so this is high pressure to low pressure, then it will move upwards because here the temperature is very low, so it will move upward. So this area becomes high pressure, this area becomes low pressure. Then it will move towards, because here we have high pressure, so automatically the other side will be low pressure. So the winds will move towards that direction, and because they are converging with the one coming from above, so they will converge and they will settle down. As they are settling down, this area will become high pressure belt. So here we can see a full cell of circulation of wind. So this cell, which ranges from 0 degree to 30 degree, is known as tropical cell or Hadley cell. Next cell is polar frontal cell or mid-latitudinal cell. It is popularly known as Ferren cell. Okay. So in Ferren cell, what happens is, due to spreading of winds, that is dynamically induced pressure belt we have, and this pressure belt is induced because of spreading of wind. So due to spreading of wind, the air rises up, it spreads. Okay, so air is rising up, causing low pressure here, and it is diverging in both the directions. Okay, as it is diverging in both the direction, we will consider this belt first. So it will move, and here high pressure will be generated. Okay, now as they will converge, this wind and this wind will be converged, they will settle down, inducing high pressure here, and the wind on the ground level, it will move from high pressure to low pressure in this fashion. Okay, so here also we can see a formation of a cell. This cell is known as Ferren cell. Lastly, we have, the Ferren cell ranges from 60 degree to 30 degree north and south. Okay. Lastly, we have polar cell. Polar cell, see, there is low pressure, so the wind is spreading. It spreads in both directions. Now we will consider this belt of the wind, or this section of the wind. Now, because the wind is moving up here, so this area will be high pressure, and now this wind will move in this direction, that is upward, because upward we have low pressure at this point. Okay, Now we have low pressure, so it will move here and it will settle down here. Because it is settling down, it will induce high pressure in this part. Okay, and then we can see at the ground level wind always move from high pressure to low pressure. So it will move from high pressure, that is high pressure belt of polar, that is polar high pressure belt, to subpolar low pressure belt. So this is how another cell is formed. That cell is known as polar cell. Now we have tricellular meridional circulation of atmosphere. With this we complete our planetary or permanent winds. The local winds, the variable winds will be completed in our next class. So that was all for today. I hope you enjoyed today's class. That was all for today. So let's meet in our next lecture. Till then, take care and have a nice day.